Here comes Matthew.
And everybody should listen very carefully, because if he's a teacher, I gotta make sure that, I hear what he says. I'll be a student today. All right, Matthew, go ahead, you're a teacher.
All right, so we started out yesterday talking about what just that was, and it's a chemical symbol, and then we moved on to the chemical formula, which is
What does a chemical symbol represent, though?
the elements.
Okay.
And then a chemical formula represents a compound or atoms bonded together, and then that's a chemical formula. And then an equation,
You did a good job.
we learned about the equation, and we learned what the pluses mean, and it means something's reacting with something. And then that we learned about the arrow, and that means it's like a product sign, like it's producing that. And then we found out that their reactants are on the left side of the arrow, and their products are on the right side.
What are reactants?
They're chemicals that are going to react with each other.
Excellent. You're doing a great job.
And then the products are the chemicals that are produced in a chemical reaction.
Okay.
And then
How about those little symbols? I'll do one more, okay? How about little symbols?
the solids start with an S. The liquids are just like an italic E or something like that.
It'd probably be a parentheses.
Oh yeah. And then the gas is a G, and then something that's dissolved in water is lowercase a, lowercase q.
What's that mean?
Like aqueous.
Aqueous. Wow, go ahead, you sit down, that was a really, really good job. All right, let's have somebody else take us a little bit further into this. Let's see. Hey, Charlotte, let's have you try it. And I don't really care, don't try to judge yourself, hey, I did a good job, just try to do the best you can, and ask yourself, hey, if I was up there, would I have done what Matthew did? Would I have done that? Okay, so, all right, go ahead.
Okay, so next we learned about classifying, and we learned like different ways that like there's like combinations, and so we learned synthesis, and it's like basically just combining two things, so like A plus B equals A and B. And then we learned decomposition, which is basically like breaking apart two things, so you would start with A and B and then you'd get A plus B. And then we talked about single replacement, which is basically where either a metal kicks out another metal, or a non-metal kicks out another non-metal.
Wow, that's really good.
And then
Go down there to number 3 and tell me why you think that's a synthesis reaction.
because two different things are combining together to make one thing.
So A plus B yields AB.
AB.
Okay. What about number 5? Who's kicking out who? Who's getting kicked out there?
So like hydrogen would be getting kicked out, so then
Yes.
it'd be zinc and chloride.
Yes. Okay. All right. Now go ahead and sit down. What do you think? Is this a good way to start today? To me, I don't know what class you came from, but we're in chemistry, and you gotta get your mind thinking about chemistry. If you could do this at home or before a test, if you could try to teach somebody what you say you learned, it makes a huge difference. I have students of mine who sign up in the art to be a tutor. Now, sometimes they've never done that before. And I even had some students of mine who went to different universities, and they actually became chemistry tutors. Now, they found out, and if you ask any tutor, here's what they'll say: "Oh, I really learned it when I had to teach it." When I started teaching, guess what? I took a lot of chemistry and stuff in college, but I think I really learned it when I started teaching it. And people started asking questions, and I didn't know the answer necessarily. So when I started teaching it, I really learned the ins and outs of it like that. So anyway, hey, thank you very much. That was a great job you did there. All right, anyway. today, we're going to finish the classification. Then we're also going to learn how to balance it. And some of you are going to enjoy the balancing. It's like a little puzzle. I think some of you like puzzles, don't you? Maybe? All right. Everybody ready? All right. I'm going to flip back over the front page. Just we're going to do one more thing that left out. What does this word here mean in chemistry? Balance is kind of like a bookkeeper or an accountant. It says, you better be able to tell me where all your money went. If I had this much money, you better tell me, well, someone here, and it better balance. What does that mean? What does it mean? If I had $100,000, you better be able to show me where $100,000 went, or you're out of balance. You get it? Do you know if you work down here at the bank, do you know you can't leave? You can't leave work if you're out of balance. If you're not in balance, you have to go to your manager and say, I'm $10 out of balance. And they have to go look for it. You have to look to see, where did you make your mistake? You made a mistake. You either cheated somebody out of $10, or there's $10 in there that shouldn't be in there, right? And so, and unfortunately, they write that down every time you're out of balance, because a bank cannot exist if, hey, we're $100 short today. Hey, we're $300 short the next day. What's going to happen to the bank? You're giving people back too much money, aren't you? And so they got to fix that. So you cannot have a bank that's out of balance. Why do accountants make a lot of money? Because people who run businesses, they have these ideas of how a business runs, and they're buying stuff and selling and paying people and stuff like that. And the accountant kind of keeps track of all that money, and he says, you know what? I'm going to buy this new bulldozer. And the accountant says, you don't have that money. And that's what accountants kind of keep track of your money. And you have to trust them, don't you? Could an accountant who is dishonest, could they make it look like you had money, but they actually were taking it? What's that called? It's not in the chemistry book, but it starts with an E. EMB. Embezzling. Embezzling money means that you took money that didn't belong to you, and somebody who's really good at accounting can make it look like the money's still there, and it's not there. And then they take off. And every year you hear about different people that get caught. I've even heard people that were, you know what PTA is, parent-teacher organization. A lot of parents might belong to a PTA, and they might raise money, and they're going to use the money to help the school. And it's a shame. It's a shame. But I've even heard of people who were the treasurer of the PTA who embezzled $10,000. Now, that means something in their life was so out of whack that they thought, I got to have $10,000. And they stole it from that. And they thought, well, nobody will know until I'll try to replace it. I'll try to replace it later. But they go to prison for that. Anyway, I don't know how we got. Oh, I know. Here's how we got in that discussion. What does it mean in chemistry? It means if you start with this many atoms in the reactants, you better tell me where they went. If I start with 5 carbon atoms, there better be 5 over here, right? You can't break the law of conservation of matter. You can't have matter show up out of nowhere, and you can't have matter disappear into nothingness, can you? Anyway, so what we had is, notice that this original equation, it doesn't make sense. Can I take one of those, and one of those, and produce this plus this? I can't. I can't. There's something wrong with that. It doesn't balance. So what you're going to learn today is how to put these coefficients in front of here. And if this is HCl, then what would 2HCl look like? It would look like that, wouldn't it? And that's what it means, 2 HCls. Okay, so anyway, we're going to learn how to balance today while we're doing this. So let's go ahead and finish our classification. Now, both of you did I was actually impressed. I honestly did think about this. I woke up and I couldn't go back to sleep a little bit. And I started thinking about school. And I thought about this class, and I thought, I don't know. Let's try it. Let me try it. And you did a great job. So is everybody okay on the synthesis? A plus B is AB, and then the opposite of that would be decomposition, to decompose, isn't it? Now this one, I gave $1. You, maybe you should get it. No, I'll let you keep it. But so Matthew said A is more likely to be a metal. He said because when they write the compound, it was written first, and I like that. That was great because in a ionic compound, isn't the plus thing, isn't the metal going to be written first? Okay, so I like that. Then I asked him about B, and he thought it was a non-metal. But wait a minute, look, Matthew, who's written first here? B. So now what do you think B is?
A non-metal.
Okay, one more time. You got the $1 because you said A is more likely a metal because when it formed a compound, you wrote it first. It's a metal. And then you told me B was a non-metal because it's written first?
Oh, I think it's C. Oh, it's metal.
No, not C. What's B?
A metal.
Okay, so here we go. I think A is more likely to be a metal, and I think B is also what?
Metal.
So metals tend to kick out metals. Now, what about this over here? Let's see who's paying attention. Zach, it's time for you to talk, okay? It's brand new, right? Brand new chapter and everything. What do you think D is? Is D most likely to be a metal or a non-metal? Which one?
Metal.
Okay, metal. Why? So when D, who does D going to kick out here? The first thing or the second thing? Who gets kicked out? Ooh. So D kicked out the second thing. Now, here, I know you had to have this. Have you ever heard of table salt be called sodium chloride? Yeah, like the stuff. Okay. It's made of sodium and chlorine. All right. Do you know on the periodic table where the metals are? Where the metals are and the non-metals? Okay. All right. Matter of fact, okay. Let's see if I haven't used this since before Christmas, so I don't know if the batteries are still good. Okay, good. All right. Here's a periodic table. Okay, Zach. Uh-oh. Oh, darn it. Come on. Anyway, not counting hydrogen, there's a little stair step here. See this guy right here? Everything below that stair step, everything. Those are all metals. Did you get that question right? Most elements on the periodic table are metals. That was easy, wasn't it? And the non-metals, including hydrogen, are right in here like that. See that? And these guys don't like to form compounds, so we don't talk about them that often. And so what we have here is sodium is a metal, right? Look over there, it's a metal. And chlorine is on the other side of the periodic table. It's a non-metal, isn't it? Okay, now, when these form ions, these are +1, this is -1. You always write the positive ion first when you write a compound. So this is an element, and this is a compound. D kicks out C. Now, why was C written second? Because C was a what? Non-metal, yes. And notice C's all by itself. It got kicked out, didn't it? But D took C's place, and D is also what? Zach? It's also a non-metal, because it's written second, isn't it? So metals tend to kick out metals, and non-metals tend to kick out what? Wait, metals tend to kick out metals, and non-metals tend to kick out non-metals. Yes? All right, so that's what it's about. Now the next one is kind of neat, and I think you'll like this one. It's called not double replacement, not single replacement, but double replacement. Now watch what happens here. AB plus CD yields AD plus CB. What? What happened there? A said, I'm going to kick you out, C. Oh, yeah? I'm going to kick you out. No, I'm going to kick you out. And so what gets formed here? If A kicks out C and C kicks out A, then what are you going to make here? You're going to what? Make what? CB plus what? AD. Does that make sense to you? All right. What I want you to do is go down here and see, raise your hand if you think you see a double replacement reaction. Yes, Gabe.
Number 1.
Yes. Watch now, watch. What's right? Silver nitrate. Get it? AB. Silver nitrate. Yes? Is that what that is? And what's this right here? AB plus what? Potassium CD. And so if that happens, A is going to kick potassium out, potassium is going to kick silver out, and you're going to have silver forming a with chlorine, a compound, and potassium is going to form a compound nitrate. So, watch right here. Eventually, I want you to be able to do this. What if I tell you that it's double replacement? Now, ready? With words. Just tell me in words. Sean, you do it, okay? Sean, silver nitrate reacts with potassium chloride to form, and it's double replacement. Tell me what's going to happen. What's going to make it? Just, yeah. What's going to form? Just say it in words. Yes. Silver chloride. What's the other product?
Potassium.
And we have to learn these polyatomic ions, don't we? What is it? I'm going to use nitrate 100 times. Okay? Everybody learn nitrate. Got it? That's nitrate, isn't it? Okay, now, do you remember the chapter where you learned how to write formulas? It is not cut and paste. It's a coincidence. Now watch right here. What's the charge in chlorine? You have to learn this, okay? Chlorine, fluorine, bromine. In a compound, what charge do they always have? -1. And silver is an always metal. Silver always has what charge? So, that's how you write silver chloride. So that's okay. Now, what's the charge on potassium? You see the chart says lithium, sodium, potassium, the left-hand column, those are called the alkali metals. What charge do they always have in a compound? +1. And what's nitrate? You got to memorize these, okay? What is it? I'm going to use nitrate a lot. So guess what? We don't have to use any other subscripts, do we? Now, let's take a look at the second one. All right? Who can I call on? You took an exam. I'm going to leave you guys alone because you guys... Aiden. Ready? AB plus CD. It says double replacement, so who's going to form a compound with who now?
Sodium. Wait.
What is it?
Sodium.
Sodium is going to form compound with who?
Chloride.
Yes. So we'll put those together. And what's the other one?
Hydrogen.
Yes.
Is that?
And what's OH?
Oh, hydroxide.
Yes. Okay. And by the way, does anybody know another way to write HOH?
2HO.
Water. Oh, that's water, isn't it? Isn't that water? HOH? Okay. Now, we got to be careful now. What's the charge on sodium in a compound? And what is chlorine? We did this a lot, didn't we? Okay. And what about H? And what's hydroxide? Hey, pretty good. We don't have to do any subscripts, do we? Okay. Everybody okay with this? All right, let's take a look at, let's flip the page. Let's flip the page over. Are you getting, is this feeling comfortable? Are you getting a little more comfortable with this? Okay, let's have, let's see. J3, ready? All right, J3, I'm gonna give you a hard one, okay? All right. Do you know the name of this compound? It is nitrate, and this is PB. What's PB? Lead. Now, remember that lead is not always metal, and so we want to figure out the charge on the lead. So what's, JT, what's the charge on nitrate? What is it? -1. I'm going to use nitrate 100 times. Huh? Nitrate's -1. You got that? Now, how many nitrates do you have, though? What's 2 times -1? Okay, so what charge must the lead have? Okay, so the name of this is lead 2 nitrate. Isn't that right? All right, what do you think the next one is? Remember that guy has chromium in it. What's that polyatomic ion? It has chromium in it. Do you guys need to have that chart out? Do you have your polyatomic ion chart somewhere? All right, this one's chromate. Now, you don't have to use the Roman numeral because it's always metal. Got that? All right, so now, J3, I put my pen there so you couldn't see it, so I don't want you to look at your paper, okay? Tell me, if this is double replacement, it is, tell me one of the products that's going to be formed. Lead 2 chromate, yes. And the lead 2 chromate and potassium nitrate. Excellent. Man, this is great. This is great. Whew. I'm great. I don't know. I feel great. Now we have to learn how to write the formulas. You said it was lead 2, right? And what's the charge on chromate? Does anybody remember chromate? Oh, so the good news is, hey, we're done there. And what's the charge on potassium in a compound? +1. What about nitrate? Hey, all right. Pretty easy, right? We do have to check that all the time. And this is double replacement, isn't it? Is this making sense to you? Yeah. Okay. Let's do one more. And let's see. All right. Now, who can I call on? Luke. All right, Luke. You're okay. You're okay. Just relax. Relax, okay? Look at number 10. What do you think it would be classified as? Does it look like double replacement like we've been doing? Is that AB plus CD? I don't know about that. Isn't it kind of like A plus BC? So what do you think you're going to classify this as?
What's that called?
Say it. Synthesis, it could be, but I'll tell you right now, 2 different things are going to form, okay? So it's not synthesis. What if I tell you that it's single replacement, okay? Let me tell you that it's single replacement, and I'm going to put my pen here so you can't see, so don't look at your paper, okay? Look up here. Who's going to kick out who? Is the metal, magnesium, is it going to kick out the first person in the compound or the second element in the compound? And I know that hydrogen is not really a metal, but it's in the same column as all the other metals, so it does have a +1 charge. So it acts kind of like a metal.
Would it be the first?
Yes.
The first one.
Yes. So what compound will be formed? If you kick that hydrogen out, it's going to be by itself hydrogen, isn't it?
Yeah, magnesium chloride.
Magnesium chloride. Now, how do you write magnesium chloride? What's the charge of magnesium in a compound?
+2.
+2. What's the charge of chlorine in a compound?
-1.
That means you had to put a 2 down here, didn't you?
Yeah.
Remember that? Now, I don't think I have $1. Let's see what I have. If I have another $1, I'm gonna give that away today. If I don't, I'll go see if I can find some dollars this weekend. Is that $1? Oh, no. Sorry. No, it says 1. Okay, that's not $1. Actually, that's worth about 16 cents in China. Darn. Okay, I'm looking here. Okay. All right, I'm sorry, I don't have any money. I'll try this weekend. I'll try to get some more dollar bills. Here's my question. Okay, here it is. Why did I write, the hydrogen got kicked out, why did I write it as H2 and not just H? Yes.
Is it because since you add 2 of the chloride of the
That's good thinking. No, but it's good thinking. I like the fact you took a chance. It has to do with something you learned in a chapter before this one. Is your hand up? Yes.
Is it because like magnesium cannot kick out hydrogen if they did not have the same charge? So, or magnesium to kick out hydrogen, they need to have the same charge, and magnesium has +2 and hydrogen has +1. So
Okay.
we had to add a 2 on hydrogen so that they would like match, so that it would be able to kick it out.
You're getting kind of in the same realm that she was talking about the 2, but I'm going to say no. I love the fact you're taking a chance, but it's something you learned in another chapter. And this is something you have to remember for this chapter, by the way. I'm going to give you a little hint. You raise your hand as soon as you think of it, all right? Darn it. Okay, wait a minute. Now, what do you think? Yes. Yes. Yeah, that was on the. I didn't do it, but when these elements are by themselves, I don't mean when they're in another compound. You can have as many chlorines as you want in a compound, but if it's just the element chlorine, God said, I'm going to make some of these elements what? What's that word? Diatomic elements. And you have to remember which ones are diatomic elements. So if you kick a hydrogen out, there's going to be another hydrogen about a millisecond later that's going to join together and make H2. All right. So I'll tell you what. I'm going to do combustion like maybe on Monday because combustion is a little more difficult. So I'm going to stick with what we have here. But I want to show you how to balance equation. I think it's kind of fun. So I'm going to do some fun stuff, okay? Let's go back over here. And I have about 4 or 5 tricks that will help you to balance an equation. And the first of all, you don't ever even think about balancing an equation unless you have all the formulas correctly written. Now these are all correctly written. I know that they are correctly written. So I go on the left side and I look here, and this is called silver. How many silvers are on the left side of the arrow? How many silvers are there? 1. Now I go to the right side. How many silvers over here? 1. Then they're balanced. Ready? How many nitrates? Here's trick number 1. If a polyatomic ion stays as a polyatomic ion, treat it like a single atom. Now how many nitrates are there? Don't say 3. How many nitrates are there? 1. NO3 is called what? And I have 1 nitrate here. How many nitrates on the right-hand side? 1. Then it's balanced. How many potassiums on the left side of the arrow? 1. How many on the right? How many chlorines on the left? 1. Chlorines on the right. Now, I'm not mean. I'm not a mean teacher. But if you have this on a quiz or a test, and you did not have to add any coefficients, I require you to write the word balanced. Now, balanced means it's already balanced. You don't have to do anything. Look at the next one. Is it already balanced? Is it or not? 1, all right, 1 chlorine, 1 chlorine. 1 sodium, 1 sodium. 1 hydroxide, 1 hydroxide. 1 hydrogen. So I have to write the word balanced. It gets a lot more fun than this. It just happened to be that the first 2 were already balanced. All right, now let's do some fun stuff, right? Trick number 2. When I look at an equation like this, I look over here and I see O2, and what do I see here? O3, don't I? You will never have an even number balance an odd number. That's not going to happen. There's a trick. What is the smallest number that 2 and 3 both go into evenly?
6.
6. What times 2 is 6? And what times 3 is 6? Now this is called the odd-even imbalance, okay? And it's an odd-even trick. Now notice how many oxygens do I have now? 6. 3 times 2, 6. And this 2 distributes over everything. How many oxygens do I have over here? 2 times 3 is what? 6 oxygens on the right, 6 oxygens on the left. I like that. Let's go over here now. How many irons do you have? Whoa. How many irons do I have on the right? 4. How many here? Well, how are you going to fix that? And you can only balance an equation with coefficients. Now does this make sense? It takes 4 irons to react with 3 of the O2s before that reaction can take place. And now it's a balance, isn't it? Now I don't write balance. I don't write the word balance now. I mean, balance means it's already balanced. You didn't have to fix anything, okay? All right, let's try the next one. I don't have any tricks. This is a pretty easy one. Ready? 1 zinc, 1 zinc. 2 chlorines. How many here? 1. Remember, don't add a subscript. What do you hear? Now, how many chlorines does that give you? 2 chlorines? 2 chlorines. But how many hydrogens does that give you?
2.
Ding, 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 ding. Are we balanced? Are we balanced? Okay. All right, let's try the next one. Oh, odd, even mismatch. Watch now. Oh, I can see it. O2. O what? O5? Ooh. What's the smallest number of those two go into evenly? What times 2 is 10?
5.
And what times 5 is 10? Whoa. 10 oxygens, 10 oxygens. But how many phosphorus? 4? Yeah. There's one more thing I want to mention to you. Because this is trial and error, you always have to make sure it's reduced. Now, reduced means, for example, what if you had put an 8 here and a 10 here and a 4 here? It would have balanced, but you're required to reduce it to the lowest number you can get. So if you see 8, 10, and 4, what can you divide all those by? By 2, can't you? So you have to always make sure it can reduce. Now, I'll show you another little trick. As soon as anybody has a 1 coefficient, and that's what this is, then you're balanced. I mean, you can't reduce it. You can't reduce it. See that? So can I reduce this? Can I reduce the 4, 5, 2? You have to divide everything? No, I'm done. All right, let's do another one. All right, now I have another trick for you. Another trick. Now this one you got to remember. This is a hard one to remember, okay? When I scan through here, I notice there's a hydroxide on one side and there's water on the other. Now, if I ever see hydroxide on one side and water on the other, I'm going to show you a little trick. If you write the water as HOH, now guess what happens? Watch what happens here. Can you classify this one now? What do you think? How would you classify it? What's the sodium doing? Is it kicking somebody out? It kicked the hydrogen out, didn't it? It says, get out of here, hydrogen. I'm going to form a compound with OH. So what would you call this one? How would you classify it? Single replacement. So trick number 3, if you see hydroxide on one side and water on the other, write the water as HOH, and not only will you be able to classify it, watch, we're going to balance it. How many sodiums on the left side of the arrow? 1. How many on the right side? 1. How many hydrogens that are not in a hydroxide on the left? 1. How many on the right? 2. Uh-oh. Now how many hydrogens that are not in hydroxide? 2. See that 2? And 2. Now, but how many hydroxides that give you? Wait, how many? I put a 2 in front of that. It's 2 H's and it's also 2 hydroxides, isn't it? How many hydroxides do you have? Who keeps saying 1? Let's try it again. I put a 2 here, right? Without the 2, it would have been 1 H and 1 OH. But with 2 here, it's 2 H's and 2 OH's. One more time. How many hydroxides do you have over here? 2. How many hydroxides over here? What? 1. So how do I get it to make 2? Everybody see that? Now how many hydroxides do I have on the right? 2, right? But how many sodiums? Uh-oh. Now, can I reduce this? Careful. Can I reduce this? You know why I can't? Because there's a 1 there. What do you think? Is this pretty good? Okay. All right, new chapter, new quarter, new semester, new attitude, okay?